Hello everyone, in this video I will teach you how to solve a problem on specific energy. So let us start with a question. A discharge of 18 meter cube per second flow through a horizontal rectangular channel 6 meter wide at a depth of 1.6 meter. Find number 1 the specific energy, number 2 the critical depth, number 3 minimum specific energy, number 4 alternate depth corresponding to the given depth of 1.6 meter, and number 5 state the type of flow. So this is the question. Here let us write the data that is given in the question. Here the discharge which is flowing from a horizontal rectangular channel is given, which is of 18 meter cube per second. So let us consider capital Q will be the total discharge which is coming out from a rectangular channel, that is of 18 meter cube per second. Then the width of the channel is given here. So let us consider B, capital B, be the width of the channel which is given as 6 meter, and the depth at which the flow is taking place is also given. Let us consider Y be the depth of flow which is taking place in the channel, that is of 1.6 meter. Now with this given data we have to find the specific energy, the critical depth, minimum specific energy, as well as the alternate depth which is corresponding to the given depth, and also the type of flow which is taking place in the channel. Now let us start finding the specific energy which is acting in a channel. So to find the specific energy we have the formula E is equal to Y plus Q square by 2GA square. So V represents here, this represents the kinetic head, that is V square by 2G. I am here replacing V with Q by A because we know that Q is equal to A into V. Then here we represent specific energy with the letter capital E, and Y represents the depth of the flow which is taking place in the channel. Capital Q represents the total discharge which is coming out from the channel, and A represents its cross-sectional area. Let us substitute all the values one by one in the next step. Y, that is given as depth of flow which is of 1.6 meter, plus Q represents the total discharge which is of 18 cumex, that is square divided by 2 into 9.81 is the value of G, into A. A represents the cross-sectional area. To find the area we have the formula B into D, that is depth of flow. Here B represents the width of the channel and Y represents the depth of flow. So 6 is the width and 1.6 is the depth. On multiplying this we get the area of 9.6 meter square. Then on substituting all the variables and simplifying the whole equation, we will get a value of 1.779. So let us try to simplify this. 18 square divided by 2 into 9.81 into 9.6 square plus 1.6. So that gives you 1.779 meter. We usually express energy in terms of meter. So that gives you the specific energy. Let us move to the second case. Here we have to find the critical depth. So we usually represent critical depth with the letter YC or HC. And the formula to find the critical depth is Q square by G whole to the power of 1 by 3, where small q represents the discharge per width of the channel. So this discharge is yet to find. So let us find the discharge per width of the channel here. So for which we have to take the total discharge which is coming from the channel, and let us divide that with the width of the channel. So the total discharge is 18 and the total width of the channel is 6 meter here. On dividing we get 3 meter square per second. So this Q value we need to put here, and then G represents the acceleration due to gravity which is of 9.81. You put to the power of 1 by 3 for the whole. Then you start simplifying this. Let us simplify. This gives you 3 square divided by 9.81 whole to the power of 1 by 3. So that is 0.9716. I am rounding the value to 0.972 meter. So that gives you the critical depth of flow. Moving to the next case, we have to find the minimum specific energy. So to find the minimum specific energy, the formula is, it is 3 by 2 times of the critical depth. We usually represent minimum specific energy with the letter E minimum minus, which gives you the value which is 3 by 2 times of the critical depth. So just now we found the value of critical depth, that is 0.972. If you do 3 by 2 times of this, you will get a value of 1.458 meter. That represents the minimum specific energy. Then coming to the next case, alternate depth y can be found by the equation. See, we have two depths here. One is the y1 depth, other is y2 depth. So the depth which is given in the question will be always y1. So to find y2, that is the alternate depth or the corresponding depth, we have to make use of the formula of critical depth in terms of y1 and y2. And the formula is yc cube is equal to 2 into y1 square y2 square divided by y1 plus y2. I repeat, this equation represents the equation of the critical depth in terms of alternate depths. So where yc represents the critical depth, y1 represents the depth of flow at the first section, and y2 represents the depth of flow at the second section. Here we know the value of yc, we know the value of y1, we need to find y2. So let us substitute all the values of yc and y1 in this equation, and let us try to simplify the whole equation at a single term. So the value of yc is, we found the value of yc, that is 0.972 to the power of 3. So let us put this in within the bracket, power of 3, then is equal to, then you put bracket 2 into y1 is 1.6 square into y2 itself is unknown. Let us take this as a square, then close the bracket, divided by, then open the bracket, 1.6 plus alpha a, close the bracket. Then you take shift solve, then shift solve. So that gives you a value of 0.6328. So you will be getting a positive value of y2, which is 0.6328. So that positive value represents your corresponding depth, y2. I repeat the calculation once again. Let us take yc on the LHS side, which is of bracket 0.972, close the bracket to the power of 3, then you press alpha is equal to, then again open the bracket, then you type 2 into y1 value, you need to put it as 1.6 square, y2 itself is unknown, just to press alpha a button, then put square for it, then close the bracket, divided by, open the bracket. Let us type the value of y1, that is 1.6 plus again alpha a, then close the bracket, then shift calculate. So you will get a value of 0.6328, which represents your corresponding depth. Then that completes the fourth case. Coming to the last case, we need to find the type of flow which is taking place in the channel. So to find that, we have to compare our y2 value with the critical depth. If we are getting y2 less than yc or the critical depth, then the flow is said to be the supercritical flow. Similarly, if our y2 is greater than yc, then the flow will be said to be the subcritical flow. If y2 will be equal to yc, then the flow is said to be critical flow. So totally there are three types of flow which will be taking place in the channel. One is the critical flow, other is the subcritical flow, and the third is supercritical flow. In critical flow, y2 will be equal to yc. In subcritical flow, y2 will be greater than yc. In supercritical flow, y2 will be less than yc. So here we have the value of y2 as 0.632 and yc as 0.972. So we got y2 less than yc. So for that reason, the flow which is taking place within the rectangular channel is a supercritical flow time. So that completes the specific energy problem, and it is one of the important question they may ask you for the examination. So thank you.